We are Team Tbcas, Truck versus Bridges Collision Avoidance System. I'm Mina Sobhi, Frank Donison, Julita Bernis, and Kim Hem. Our project is, we found that there is a clearance issue for trucks approaching bridges. So we are designing integrated system to be mounted over the top of the truck, which has a sensor will transfer the truck height to the phone using Bluetooth, and then we have an app over the phone that will is linked to a GPS that will determine the position of the bridge and sends this data over to a database. And then we have another app that has an alert to notify the driver of any hazard on his way.
All right, so just to expand a little bit on the design overview, what we did was we designed a mount that uses magnets and a lot of super glue in order to mount on the top of the truck. The application is going to take into account a lot of the height of the user's truck, so that will have to be input. But as you can see, we're going to put it right on top of the truck, point straight up, and we have a LiDAR that will be measuring the distance of any bridge and or obstacle that passes. That will be transmitted to the cell phone, which Julita designed the app, and she'll speak more about that in a little bit. But that will be able to send that to our database, which we used a third-party Firebase in order to represent what we wanted to do. And that will be able to save the height that we track and also the GPS location in order to be used in creating apps in the future if you want to expand on routing systems that are currently here. And overall, the design is $228 to about $240, depending on the types of materials that we're using to create the mount and have everything put together.
Alright, so he already explained it. There's two applications. The first application is going to communicate with the Raspberry Pi via Bluetooth. So when the Raspberry sends over a variable to the application, it will calculate that variable with the user's truck height to get an overall height of the bridge, and it will get the coordinates of that location where it got the variable and send it over to a database via cellular data. And also, if another different user passes over that bridge and the bridge happens to be like renovated or modified, it will update that value in the database as well. So the second application is the warning application. So a user will enter the truck height on that application, and as he's driving, it will look through the database to see what bridges are shorter than that truck, and then it will also look through the latitude and longitude and the position of where the truck driver is. And if he's approaching that bridge within 0.6 miles, it will send a warning. And also it will send a second warning once he's getting a little, like 120 meters closer to the bridge. So Yoshi can talk to you more about the LiDAR.
A quick mention on the testing phase of our project. When we were testing this clearance, the detection of the bridges under 40 miles per hour, we got a percent error of about 4.2. I know it doesn't say it on the slide right here, but we kept testing it even after we turned this in. And after 40 miles per hour, above 40 miles per hour, we will have a error percent of 5.8%, which is way better than the 33% that we got originally. That was due to like static noise, but we were able to get rid of that. And also, at under 40 miles per hour, we will detect it 8 out of 10 times. So 10 times you'll pass through the bridge, only 8 of those will be detected. And at higher speeds, it'll be a little bit less. It'll be about 50%. But that's better than getting an error, a bad reading of the bridge sent to the database. Well, and we open the panel up for questions now.
So if you're driving this truck around and you're capturing bridge heights, you have to have a cellular account to upload that data, or do you store it?
Yes.
Or how do you get that? Where do you get that data?
Since we're using the Android app, which is on a mobile device, it should have data. If it's not able to communicate through an internet channel, we're not able to send anything to the database.
I think to be more specific for your question, currently we don't have a requirement to have a user login, but that would be something that would be a quick and easy fix and would be needed once we started giving it out to consumers in
So,
order to confirm truck heights.
what's
that
the
are-
connection between the device on the roof and your cell phone? Bluetooth?
Oh, so
Bluetooth.
Bluetooth, yes.
Okay, all right, so it's Bluetooth that way, and then cellular, but if you're not, where there's any cellular, do you store it in the phone, or you just don't do anything with it?
We don't have a way to.
Don't have to,
fix
okay,
it.
all right.
Who defined the problem for you?
It was a problem we.
Julita is the one.
So you all got to define your own?
Yeah,
Are
we
are you
created-
familiar with the Dallas company called OmniTrack?
I'd have to say no.
Hmm?
There are systems out there that may be run with.
No, they're the people that know how fast you're going on the road in trucks. They also know if you have things inside the truck or not,
Okay.
and that sort of thing. So it sounds like something that they would be interested in.
Definitely, and I think it would be important to note as well that there are companies out that have routing systems that try to take care of all these things that we're working on. One problem that they have is they don't get, the databases that they use aren't updated as often as they need to be, and you get a lot of misinformation and unreliable information.
No, I like the automatic crowdsourcing. That's a good.
Well, yeah, but you
good
need to
idea.
use something like Google Maps API, which is, you can use
And
it
we
free.
tried
If we
that.
tried using it, just couldn't get it done in time.
Yeah,
like,
because
it's
that's,
just
I mean, they have really good update, or Wise, which is Waze, I mean, which is even better, and all that you can put your stuff in.
Unfortunately, with Waze, because I did try to get their API, they won't release it unless you sign contracts and
Yeah.
do all kinds of crazy
Well,
stuff.
you should tell them you're a student, trying to do something, you know?
How do you get the driver's attention? Is it, you just send them a text message?
No, so the application, the second application will post a warning. You see how it has numbers there? Well, the second application looks very similar, but it'll say warning approaching bridge. And also we wanted to implement a
Wait,
noise.
I have a phone, and it doesn't talk to me normally unless I
Oh.
push buttons.
Okay.
Does it make
So
any
what you
noise?
would-
What's it gonna do?
the second part was to add the noise.
Unless it's a Richardson, weather thing.
Yeah,
I mean,
text
that-
message. I think that could be our alternative, like, backup safety, so to make sure that these users are getting the warning. Because they do get it, like, it'll flash on the screen, but if you're saying you had to push a button before you.
Well, yeah, my phone's about.
You make a noise.
Yeah.
You
It's
need to make a
gotta do
noise.
something.
Yeah.
Just
it's
a
gonna- it will
notification.
be, yeah.
If I could add, the main constraint of our project was in order to save the data for other routing systems to be more reliable and update their codes. The warning app was something that Julita did extra, so it's a function that we did not define as one of our main goals, but she was able to do that because it is something important and makes our project a lot cooler.
Why do you have this error? Why could it be more precise? It seems to be pretty high error.
Right, so as Yoshi was mentioning earlier, this is, we turned this in last week. Of course, we did not stop working. We had a lot of static errors, so we were getting readings even when we were not under bridges. Thankfully, within this past week, thanks to Yoshi's hard work, we were able to eliminate that error. So we've got under I think it was 5.8%
Yeah,
error at the
5.8%
very largest.
higher.
So we've been able to get that error down.
That's height error, basically in feet or
Centimeters.
centimeter, okay.
So what do you attribute, you say that you're not getting readings every time you go under a bridge. What do you attribute that to?
It's the algorithm that's correcting all the static because we're taking so many readings at a
Mhm.
time. It gives us random numbers that don't match anything. Like it'll read something into a clear sky. So I believe he used the median and mean in order to check for variances. So if you get something way too quick that doesn't match anything we're looking for, then it'll ignore it. So a lot of times when we're passing under a bridge too fast, we ignore some things that we want, but we decided that was better than saying there's a bridge where there's not one.
So if I were to take your LiDAR detector out there in the parking lot, just point straight up in the air, I'm gonna get random readings
Not
that
any-
are not infinite?
That's
Oh,
what
well,
was-
whenever you're static,
Raw data.
whenever you're static, you won't get too much noise. But whenever you're in a moving vehicle and it's bouncing, that's when we get the
Okay.
noise.
All right, let's thank the team.